Here we deduct the differential equation of central orbit in resisting medium, where the resistance varies with velocity. Right? Now here we first let central force, this is equal to capital F, and the resistance force R, this is equal to K into V, because it varies with velocity and K with the variation constant. Now we draw a rough sketch of the orbit. Let this is the initial line and this is the pole, and let it be the orbit, central orbit, and the particle at any time t be at t, and this is the radial direction and this is the cross radial direction, right? And in central orbit we know that there be no resistance force, there are only central force. It acts along the line PO, right? And this is the force F, and we take it be minus F because it towards the origin or center of force. Now we draw a tangent at that point, and we know that along the tangent velocity always act. Okay, velocity along the tangent, and let it be the angle between tangent and radius vector. This is phi, so it also be phi, and this is pi by 2 minus phi, because this is radial and this is cross radial, so this angle is pi by 2. Now the resistance force always act opposite to the velocity. Okay, and the resistance force is this. This is the resistance force, and this is equal to K into V. So the component of resistance force are along radius vector and perpendicular to the radius vector are given by. Along this we get, this is R into cos phi, because the angle of R and the radius vector is phi, so this is R cos phi. And if we take the component of R along the cross radial, so we draw cross radial direction in opposite, and this angle is also pi by 2 minus phi, so this is R sin phi, because cos pi by 2 minus phi, this is R sin phi, and this is equal to kV sin phi. So in the positive direction of cross radial, this is minus kV sin phi, right? Now we let the point P, this is R theta, and this is theta, this is R. Now if there be no resistance force, then the radial acceleration Fr and cross radial acceleration F theta, and we get the equation of motion, otherwise resistance force in central orbit, are given by the first equation of motion or radial equation of motion is Fr, this is equal to R double dot minus R theta dot square, and this is equal to minus F. And since there be a resistance force, so there is another force, this is R cos phi, so this is kV cos phi, because R equal to kV, and this is also negative because this is towards the O, so the equation of motion becomes minus kV cos phi. And we know that cos phi, this is equal to dr ds, and sin phi, this is equal to R d theta ds. What is ds? Let for ds we let A be the initial point on the arc from where the arc length measured, and ds be the elementary arc length, right? And we also let AP, from A to P the arc length is S, and ds be the elementary arc at P. Now we put the value of V, that is minus of F plus K into ds dt, this is equal to V, and cos phi means dr ds. Okay, so the first equation becomes r double dot minus r theta dot square, this is equal to minus F plus K into ds cancel out dr dt, and this is 1. And another equation of motion, that is cross radial equation of motion, is given by f theta, this is equal to 1 by r d dt of r square theta dot, this is equal to 0 if there be no resistance, and here another force act, this is equal to minus kv sin phi. We put the value of sin phi, this is equal to r d theta ds, and this gives minus k ds dt into this is r d theta ds. So we get 1 by r d dt of r square theta dot, this is not theta square, this is theta dot, and the right side ds cancel out, minus r into d theta dt, that is minus r into theta dot. So from this relation we get d of r square theta dot, this is named as equation number 2, d of r square theta dot by r square theta dot, because r theta dot and here r, so r square theta dot, this is equal to minus k into dt. We make a mistake here, this a k, okay, there be a constant k, and by integrating we get log r square theta dot, this is equal to minus kt plus c, right? By integrating we get. Now to find the initial condition, now to find the integrating constant c, we let an initial condition, that initial moment of momentum or angular momentum, moment of momentum is h0, and initially we get r square theta dot, this is equal to h0, because we know that momentum h, this is equal to r square theta dot. This is a standard result in central orbit. Okay, so initially we put r square theta dot, this is equal to h0, and initially t, this is equal to 0, so we get from here c, this is equal to log of h0, and putting the value of c in this relation we get log r square theta dot by h0, this is equal to minus k into t, so r square theta dot, this is equal to h0 into e to the power minus k into t, and from this relation we write this relation here, and this is theta dot, this is equal to 1 by r square into h0 into e to the power minus kt, and this is also written as theta dot, this is equal to u square into h0 into e to the power minus kt, and we name this relation as 3. Okay, and we put 1 by r square, this is equal to u square, because in central orbit we know that r, this is equal to 1 by u. Now from this relation r, this is equal to 1 by u, we get dr dt. This is equal to minus 1 by u square into du d theta into d theta dt. And we put the value of d theta dt from 3, we get minus 1 by u square into du d theta into u square h0 e to the power minus kt. And this is given by u square cancel out, this is equal to minus h0 into du d theta into e to the power minus kt. And finally we write the result r dot, this is equal to minus h0 du d theta into e to the power minus kt. And we name this result as 4. Now we try to find r double dot, because we put the value of r dot, r double dot, theta dot all in the first equation, and we get the final differential equation of central orbit in resisting medium. Okay, now here r double dot, this is equal to minus h0, this is constant, and the derivative of second term, this is equal to d2u by d theta 2 into d theta dt, because this is the derivative with respect to t, but here we make the derivative with respect to theta, and this is d theta dt. And e to the power minus kt remains fixed in the first term, and the second term minus h0 du d theta into the derivative of e to the power minus kt. So this is minus plus k into e to the power minus kt. Okay, and we get by putting the value of d theta dt again, from here we get the relation minus h0 d2u by d theta 2 into u square h0 e to the power minus kt, and here is another minus kt, so this is e to the power minus 2 kt plus h0 into k into du d theta into e to the power minus kt. Now we put the value of r double dot and r dot and theta dot here, that is in the first equation. We get the result as, this is r double dot first, minus h0 square into u square into d2u by d theta 2, right, into e to the power minus 2 kt. This is e to the power minus 2 kt. This is the first term, plus h0 k into du d theta e to the power minus kt. This is second term, minus r theta dot. R means 1 by u into theta dot square means u to the power 4 into h0 square into e to the power minus 2 kt, because theta dot square, and the right side is minus f, sorry, this is minus f minus k into dr dt, because this is, sorry, this relation minus f minus k into dr dt. So dr dt means this relation, so this is minus plus h0 du d theta into e to the power minus k, right. We put the value of r dot, theta dot and r double dot in 1, we get the result, and clearly we see that this term in the left side and this term in the right side are same, so these two terms must be cancelled out. Okay, and in the left hand side term there is a minus and there is a minus, so we take common minus and cancel out minus from both sides. Okay, so in the right side there will be only f, and in the left side we take common h0 square and u square, right? So we take common h0 square into u square, and there be d2u by d theta 2. This is the first term, and this is plus u, because we take common u square, there be u cube, and also we get common e to the power minus 2kt, right? And we get the result as d2u by d theta 2 plus q. This is equal to f by h0 square u square and e to the power 2kt. We get this is in the right side, so it is positive, and this is our required result, or this is the differential equation of central orbit in resisting medium where resistance varies with velocity.